Hello! Welcome to Cyber Mentoring Monday. I am Tiberius. Alright, on OnSystemShellDredd 1. So let's boot that box up. Alright, let's see. Okay, started on this IP address. We will, even though I apparently barely update these, on OnSystemShellDread. Right, let's add the IP address into Notion here. Yep. Do auto recon, use my config file, paste this, and there we go. Alright, we're a TCP port 21, which is probably going to be FTP, so let's just do an FTP and see if we can even get anonymous. Anonymous, login successful, excellent. Let's do an ls, there's nothing, ls-la. Yeah, there's a .hana directory. You can tell it's a directory because there's a D right there. So we'll cd into .hana. So the reason it didn't show up when I ls is it's hidden directory, so I should probably do that all the time. Okay, there's an ID RSL icon. Oh boy. Oh, hang on. Connection refute. Alright, so there's a port we have to find, which is probably going to be this 61,000. Okay, hang on. Bad permission. I need to chmod 600. And then just resend it.
We are in.
Okay. Well, the good news is only 6% of you voted. I did it in under 2 minutes as well. That's a good. Auto recon didn't even finish. Like I'd already got shell at this point. Boy. Alright. Cat the local. Let's actually solve this properly this time and submit the flag. Do we even bother doing... If that was the user, do we even bother doing a vote for how long it takes me to get root? We can just stop this timer now. Like, do we even bother? Everyone's just gonna vote yes. I could do a 5 minute. Like, will it take more than 5 minutes? Is there a point to it? You think 3? Alright. So another prediction. Where's my root shell? Will Tiberius get root in under 3 minutes? We're going to do sudo-l. There's no sudo. Ooh. Alright. So let's use hack tricks. Let's find some SUIDs. Mork, I'm guessing, is... Yep. Oh, it's a file read? No, we can just do this. Nope. Do we have to do bash and dash p? Which Mork, I guess, is used in Mork. Interesting.
New subscription received.
Limited issue ID. Here we go.
Gratitude dispensed.
Yeah, I don't know then. I mean, I guess we could just read the... There's no sudo. And I can't use it with... we can do this, though, and try and grab the shadow file. Right, exactly. And then we can try and just crack this password. Like, I can just put it into CrackStation, I guess. Will CrackStation take that? No. Okay, so we're going to have to do... Yeah, this one might be a loser. This... Yeah, maybe the ID RSA. Oops. Nope. Well, it's not like in this. I'm guessing you probably could write to a file. Yeah, I'm not going to get it. Well done, people. Choose outcome. No. There you go. That's what happens when you gamble. Yeah, because it looks like with Mork, because it's running like it's running as awk. So even if you do run this system, you cannot break out. It's got a limited SUID, which means, yeah, we have to do... creds in the root directory. The problem is, can we even look in the root directory? No, we can't. Yeah. I mean, technically, we probably could have done this, but that's cheating. I want a shell. That doesn't count. Like, that thought did cross my mind, but... if you can read files as root. First unshadow? Yeah, maybe. I'm just trying to see. Unshadow? Yeah, I guess. Alright, so we want to do... No, IDRSA wasn't there. We already tried that. See? No such file directory. So what we want to do is we want to do etc shadow. And we'll copy all of this. Put a shadow file in there. And then we'll cat etc password. And do this. Okay, then shadow. What does it want first? Password file. Oh no, wait a minute. Password. Is password file the actual password? No, combines password and shadow files. Right, that makes sense. Yeah, there we go. I guess just crack. Well, then we can just use this. Honestly, doesn't look like it's doing it very well. I wonder if there's something else we can use. Why didn't this... So this doesn't work because presumably, yeah, it's running... Even if you run bin bash, it does it as a... It doesn't keep the... I actually wonder what happens if we just run this in this. No, we're still... Is there a way to write using mork? Interactive set unbuffered writes to SDL and line buffered. Maybe this? Okay, this option. Sets unbuffered writes to STD out and line. Yeah, the problem with STD out is we're still running. We're still running mork in a bash shell that's running as Hana, so the redirections will occur after the fact, after mork's been used. Is there supposed to be a freaking way to get shell on this? Yeah. Honestly, I'm just trying to think of any other uses. It's a rabbit hole? Could be. Oh, there's CPU limit. Does CPU limit work? Ah, did I just miss this one? I did. If
New
only we'd
received. Dispensing gratitude. Gratitude dispensed.
Yep. That was it, chat. Oh, if only I'd spotted that one first. There was a CPU. I just spotted mork. That's all. I mean, I go down the list. Mork was there. CPU limit was there. Yeah, sometimes that happens. Alright. Well, we can stop cracking this. I mean, I had 3 minutes, you know. Oops. Apologies. What's like the biggest amount that someone lost? I mean, to be fair, I took way longer than probably even 10 minutes. Any questions about that? So yeah, just missed this one. I mean, I didn't miss it. I saw mork and went for it. But yeah, I mean, obviously if mork doesn't work, you can always go back to this and see. All the rest of them seem to be pretty standard. Okay, so what is web cache poisoning? I guess I should probably explain that before we start the lab. There we go. Alright, so what is a web cache? Firstly, a web cache is a server that sits in front of a web server. And it processes the HTTP request before they get to the web server. And basically this is how a web cache works. So you start at start, it receives a request. it will have a bunch of rules to determine whether the request is for some cacheable resource. Now, usually, there are things you want to cache. Images, right? A lot of anything that's static content you really want to cache, right? There's no point in asking the web server to send, you know, if say an image is 500 kilobytes, there's no point in getting the web server to send that 500 kilobytes for every single time a user needs that, right? If you can just cache it and have the web cache send it instead. Okay? It basically stops the web server from being overloaded by requests for static content. So anything static needs to be cached usually. So images, CSS files, JavaScript files, fonts, right? Stuff like that. Like stuff like that can be cached. The way a web cache usually does this, you have a set of rules, and you say, okay, any GET request that is for a resource that ends in .jpg, .png, .gif, right? Or .css, .js, etc. If the path of that URL ends in one of those, then we can cache it. All right? If it doesn't, then we don't cache it. All right? It's important to note that it checks the path and not the full URL. It will use the full URL, right? But what it checks against the actual whether to cache something or not is usually just the path. So in this case, if something ends in .css, then it's probably going to be a CSS file. So let's say we have requested a CSS file. The next question it asks is, does the web cache have an unexpired cached version of the resource, right? And so what this does, effectively, it generates what's called a cache key. The cache key is made up of the host name, the request type, so get, post, etc., and the path plus the query, right? So if it was, I don't know, /images/test.jpg $v = 10, right? That forms part of the cache key, that including the v = 10 bit. And so what happens is if somebody requests that, it generates a cache key based on their request. It looks up in its cache, hey, is there anything matches this cache key? If there is, it also checks whether that when that was cached, and it sees has it expired, right? So it'll have an expiration date. So usually, you know, you can cache images for, you know, let's just say a day. So if the cached image is older than a day in the cache, then it will request the cache version, right? So no, it will request the file from the web server instead. But pretty much, if it's a request for a valid cached resource, cacheable resource, and the resource is cached, and the resource that's cached is not expired, it will just fetch that out of the cache and send it as a response, right? No part of the request will actually hit the web server. However, if any one of those conditions is not true, it's going to send the request to the web server, okay? So for instance, here we have, is the request for a valid cacheable resource? If it's not, say it's for a .php file, then the web cache requests the resource from the web server and returns it to the user, right? Without saving it. However, if it is a valid cacheable resource, so it is a JPG, but say that the web cache has a version of this JPEG that is expired, right? So nobody has requested this. Say that a JPEG expires after a day in this web cache, and nobody has requested this specific JPEG in 2 days. So there's still a JPEG on the cache, but it's expired. So the web cache then requests the resource from the web server, and it saves it, right? So it says, hey, can you give me this JPEG? Web server returns the JPEG to the web cache. Web cache saves it, puts an expiration a day in advance. and then it returns the JPEG back to the user. Okay? But if that cached JPEG was not expired, it just returns the cached version, right? So nothing gets sent to the web server. So there's two instances where the request makes it to the web server. There's one where it doesn't, and there's one where the cache processes the response, okay, before sending it on. Does that make sense to everybody? Okay, let me put this back. All right, so unkeyed headers. So what does unkeyed header mean? So you know I said there's a cache key, right? And the cache key is generated from the request type, get, post, etc. Effectively the URL. So basically the host name plus the path and the query. Okay. So that's how the key is generated. That's all that goes into a cache key, which means effectively, if you have if you request, say, images/test.jpg, right? Let's just do this 1.1. Post is example.com. Okay, so the cache key here, right, is going to be get, probably just example.com and images/test.jpg, right? I mean, it's in some format. It really depends on the web cache, but effectively that's all it takes from this request is this stuff. Okay, and if there is another request, right, like this, the cache key now is that. Okay, so even though these two requests are to the same thing, really, they have separate cache keys, right? And this is why, by the way, if you visit certain websites, wonder if this does it. I think WordPress does it. So let's just go to WordPress. And come on. Here we go. Right. Okay. So, where'd you go? Right. So this script, right, is for a JavaScript file, and it has this v equals and then this number here. All right. The reason it does this isn't for web caching reasons, it's for browser caching reasons, but the concept is kind of the same. So a browser will also cache JavaScript files, because usually when a JavaScript file is sent, as part of the response, the web server will say, hey, you can cache this. This doesn't change that often. All right. And so the web browser will say, okay, I'll cache this. And then whenever I load this page, if this URL is the same as one I have in my cache, right, and the cache isn't expired or whatever, I'll just load it from my cache instead. Does that make sense? But it uses the same concepts of the cache key, right? It generates a cache key. It's basically just this entire URL. So that's fine, except for when you want to update bundle.js as the web administrator. Say there's a massive bug in bundle.js that's being exploited. There's some cross-site scripting vulnerability. Say you put a fix in. Well, that's great if you're a new visitor to the site, because your browser will request this. But if you are using a web browser, you've visited this site before, like maybe the day before the update, now you have this vulnerable version in your cache. Well, that's what this V is for, right? Version. So as long as you update this version in the source code of this page, presumably this page, by the way, is not cacheable. It's considered dynamic content, so the web server should tell the browser, hey, never cache this, just keep loading it every time. Right, so now when the browser loads this page again, because it's not cached, it'll load the page, it'll see, oh, actually, this is completely different. This version is different to the one I have cached, therefore I need to fetch this. Alright, and so it will re-download the bundle.js. So that's why you see, if you look at the source code for most websites, when they're dealing with files that don't change often, but still sometimes change, there'll be this version thing. This does absolutely nothing, right? Usually a URL parameter will change something. Yeah, they're like dynamic, like a UID equals 1 will load the user with the UID 1. And if you change it to 2, it'll load the user with UID 2. This version number does nothing, right? If we were just to open this up, okay, and change this to 6, it does nothing. We could probably even actually do something like curl pipe into SHA-SUM. Oh, that's view source. That's probably not the best thing to do then. I wonder if this will work. Okay, so now if I change this to a 7... Yeah, alright. So I changed the 6 to a 7, but we get the exact same hash. Okay? Nothing is reliant on this. It's purely to defeat browser caching. So, you have a cache key, but a cache key only takes this HTTP request type, it takes the host name, and it takes the path plus whatever this is, right? That's all it does. So, this unkeyed header literally means it's a header which is not part of the cache key, because headers can be if you configure a web server that way, but that's a web cache. But it's a header that's not part of the cache key, but the header changes something in the response. Okay, so let's say you have this x test header equals Tiberius. Okay, and say that for some reason, let's say this instead was a JavaScript file, right? Okay, and when you send this x test header, somewhere in this JavaScript file, var a equals Tiberius. That happens. Okay, so if this header wasn't there, maybe it just sets var a to something like default. All right, but if the header is there, it sets it to Tiberius. However, the cache key is the same, right? And so, if you now send this request with this header, okay, if you send it enough times, the cache key will say, hey, this file's being requested a lot, and I haven't got a latest version of it, so I'm going to cache this response, right, with the Tiberius thing. Now, if somebody comes along after it's been cached, anybody, like a victim, and just sends a regular request to this images test.js, right, even without this header, because this header, the result of this header, this var a equals Tiberius, has been cached, they'll get it as well. So the cache server will respond with the dynamic content, even though we haven't set the header. And that's because this header changed something in the response, and the web cache cached it based on the URL only, effectively. Does that make sense to everyone? If you can find an unkeyed part of the request, in this case it's a header, there are other things that can be unkeyed. If you can find something unkeyed that changes the response in some predictable way, you can send your request with that unkeyed header, right? You can send it repeatedly until it's cached. Yeah, just basically, you can send it with burp repeater or intruder, honestly. It doesn't matter. But here we go. Let's just make sure this is still up to date. Right, exactly. We can force web caching and poison it. So we'll show you what we mean by this. Let's open this in burp. Okay. Right, visits the site's homepage. Okay, so what we did was we loaded this homepage in here, and sorry, we're gonna go back to burp, go back to the proxy. We're gonna grab the homepage, which is this one. Right click, extensions, param miner, guest params, guest headers. Okay. Let's do 20 threads. Oops. Canary. Oh, yeah, we need a dynamic cache buster. Okay. So what this is doing, if I go to logger, param miner is sending a request, and it's adding some weird headers, right? This is just to make sure that additional headers don't trip anything up. So basically, I'm pretty sure this bit is testing the limits. So you can have a header with a value that's one character. You can have a header with a header key as one character. Then we get to where it actually goes off. Okay, here we go. So what it's doing is it's just going to spam the server with requests. And it's just going to add tons of different headers. Alright. So these are all random at the moment. This part of the test is seeing how many headers can we actually set before the server says, hey, that's too many headers. Looks like we can set at least more than 200. So at some point it's going to max out. And then, okay, here we go. So at this point, you'll notice now, instead of random headers, so how many did it send there? I forget, but it starts sending actual headers that it has in its dictionary. Okay, so hey, an old sec fetch site, access control, allow credentials, cache control, contact, etc. It's just going to send a bunch. It's figured out, based on that previous testing, it can send this many headers without the server bitching about it. So what's that? Probably over 1,000. It can send over 1,000 different headers in one request. Apart from this, duplicate header names not allowed. Whatever. So, okay, here we go. So basically, this is all it's doing. It's just going through its dictionary. 1,000 at a time. And what it's doing as well, when it gets a request that it knows is good, like this 200 okay. So obviously when we had that 400... right, it disregarded this request. It was like, oh, okay, we need to test them more. When it gets to 200 okay, though, you notice it's using different but very similar values. These are all slightly different. Okay, so once it finds a 200 okay, it searches the response. So it's going to search the response for this. Okay, it doesn't get it, but if it did get it, it would know. Okay, this header, right, when given this value, reflects it back in the response. So, I think it might have found something. So what we'll do, we'll go to target and click that. Cache poisoning, secret input header. We don't even really need this bit, but okay, secret input header. Unlinked parameter identified. Found an unlinked parameter. X forwarded host. It found origin, X forwarded host, origin. Yeah, okay. So effectively, let's see what this means. So this X forwarded host header was added. Right. Let's copy this, and in this response, paste it. Oh, look, it got reflected back here. Okay. And in request 2, what it did, this is the clever thing about param miner, is it sends the same request, right, as request 1, but it adds something that should invalidate the header. So in this case, it added 6 random characters after x forwarded host. I think it used the same... No, it didn't. Okay, it used a different value. So it's just double checking... Okay, yeah, that's fine. It's basically it does a little check to make sure that it's actually this x forwarded host that's the thing. And it confirmed it there. I wonder what Origin did. I don't know if Origin... Did this work? Oh no, okay. Right, that was a false positive because duplicate header names. There was already an Origin header, so that's why that one didn't work. So the actual header we care about is this exported host. And as we see, we go back to request 1. Actually, I think it was this one, yeah. So in this case, we search this again. We see that the value of that header is in here, this resources JS tracking, right? Which means if we manage to poison the cache with a value that is effectively our domain, and we just set up /resources JS tracking.js, we can then host a JavaScript file and hope that somebody visits it, right? So luckily we have this exploit server, which is great. So what we want to do is set that up. So we want to make /resources. So all I'm doing here is I'm saying, hey, if anyone visits this URL, right, we're gonna respond. What was the challenge? What did it want? Alert document.cookie. Okay, so what we're gonna do, we copy this. So this is gonna be a JS file. I know I've copied extra. Because this is a JavaScript file, you don't need any like script tags or anything. It's just gonna run this. So let's store it. And now if we load this page, all right, let's just load it in the browser. Yeah, there we go. Okay, alert document.cookie. This is something we control now. So what we want to do, we want to go back to our original request. We'll send it to repeater. What I'm going to do now is I'm going to turn off param miners. So dynamic cache buster is an interesting thing. If it's checked, what it does, if we send this GET request, right, it looks like this is what's sent, but what's actually sent, we go all the way down. Oh, is it still running? Okay, I think it's actually still running something. But if we scroll up to where the repeater tool was, or maybe not. Ah, there we go. Okay, so this is the repeater tool. This is the request I just sent. You see it adds this. All right. This is what it means by dynamic cache buster. What is a cache buster? Well, remember what I said earlier about the cache key? It takes in this, right? It takes in every single parameter that's sent in the URL. Okay, so in this case, v equals 10. That's formed as part of the cache key. A dynamic cache buster, at least in param miner, what it'll do is it will add to every single request a random parameter here with just a value of 1. Okay, but every single one of these is random. So if I was to go repeater again, all right, so this one was HY. I'm just going to copy it. Let's scroll down again and see if we can find where I just sent it there. All right, so the one we sent originally was HY1T. This one is KY4X3. Okay, so what effectively this does is it basically causes the cache key to be different for every single request we send. This is useful when we're doing stuff like trying to find cached headers, because it means that we're not actually fucking the cache for anyone else. right? Because nobody else is technically going to this URL. We're the only ones going to this URL, so we should be the only ones who the cache key affects. Does that make sense? However, I don't want a dynamic cache buster right now. I hope that doesn't actually... Okay, that's good. So what that means, I'm going to add it myself. So all we're going to do is we're going to do, I don't know. Parameter should be fine. I use it on production servers, yeah. So we'll use dynamic equals, let's just do 1. Alright. So effectively, what this means is unless somebody else is going to this URL with dynamic equals 1, nothing should be happening. But what we're going to do is we'll do our in a sec. What I want to do is use the X cache. We're going to get the we're going to get the host name of my exploit server, and we're going to get the name of that field. What was it? X forwarded host. We're going to add it down here. Okay. We're going to send that, and we're going to double check it worked, and it did. Okay. In this case, though, so because this is the lab environment, it's actually helping us by saying, hey, by the way, when you sent this request, the cache said, hey, I don't have this cached, right? So it's a miss. So in this sense, Xcache miss means this is the response from the web server. All right. Now, you don't get this in real life. So what you actually have to do in real life is you have to send this a bunch of times with this header in, and then you take it out, send it again, and see if the header value is still in the response. Okay, that's how you test for this in the real world. But I mean, we can try that now, actually. If we just take this out, send it. There we go. It actually worked. Okay. So if I now go and copy this URL and paste it in here. It may have just got uncached, actually. Oh no. Oh no, it did, okay. Right, so that was uncached. So let me send it again with the header. Okay. Refresh. I need to double check where it is. So it's underneath, it's just underneath the body, okay. There it is, alright. So this request in the browser, right, didn't include this X forwarded host. We can actually double check that. Right, here it is. Right, no X forwarded host. However, it still grabbed this. Right, it's still reflected back. So effectively we poisoned the cache. And you can see there's an X cache hit. An X cache hit means, oh yeah, I had a cached version of this file, here it is. So this file is from this response is from the cache. Does that make sense? So I think if we actually just refresh this, it should, as long as the cache is still active, it's not. Alright, let me just resend it. So like the cache on this, I think resets every few, maybe every 30 seconds. I don't quite know why this isn't executing the. Oh wait, what? Let me just keep doing it. See if we get it again. So this, yeah, this didn't have the cache. Okay, here we go. This is cache now. If I now refresh this, there we go. We get an alert. Okay. So what was happening there when I was refreshing it didn't give me the alert. The cache had basically been deleted. So the cache had expired. I was getting the regular page back again. So now, how do we exploit this? Well, so far we've been basically setting this x-forwarded host header with this dynamic equals 1. If we just remove this, right, now we're requesting a page that most people are requesting, right? The index page. Almost everybody goes to this. And we know actually for a fact that there's an unsuspected user regularly visits the site's homepage. Okay? So we're going to keep sending this request with this x-forwarded host. We send it, there's an x cache miss. Now there's a hit. Now if we keep sending it just to make sure it's kept up to date, eventually it's going to turn to lab solve because the user is going to browse to the page and our exploit, our host is going to be reflected back even though they obviously aren't sending the header. There we go. So let's go back to the exploit server. Access log. So, yeah, here we go. This is them. Right? There's the internal IP address of the user. Grabbing this. And the reason they grab it is because when they loaded this page, we poisoned the cache. Are there any questions about that? Alright, if you have dynamic parameters, it doesn't make sense caching it, does it? If you link the SQL, same. Yeah, like there's no point to caching dynamic pages anyway. So they don't get cached. A web cache is purely to cache files that shouldn't change that often. So we're talking about images, CSS files, JavaScript files mostly. And the point of caching them at all is just to take some extra load off the web server, right? There's no reason why the web server, which is running the application itself, should even have to process requests for images, you know? Let the web cache do that, and then let the web cache forward any requests that are for dynamic content to the web server. So the web server is only dealing with dynamic content, unless, of course, the cache server needs to update its cache and grab a static image. Opinion, TryHackMe versus Hackbox versus Web Security Academy. Web Security Academy is a whole different ballpark to those two. TryHackMe and HackTheBox are great for CTF stuff. Web Security Academy is just on another level. It's basically it's pure web app, and it's free, so it's really good. But there's a lot more advanced stuff in Web Security Academy than in HackTheBox and TryHackMe in terms of web app stuff. How do you craft your payloads and engagements? Well, firstly, I run Param Miner, and that's the thing. You need to run Param Miner because it finds the headers, and sometimes Param Miner will find headers that aren't even useful for web caching. But like for instance, a lot of APIs will have hidden parameters. Usually they're boring, like sort. Like you may have an API which just lists users, and it says, hey, all you need to do is just get/users, and it'll give you a list of users. That's it. There's no parameters. That's what the documentation says. You then run Param Miner against it, and Param Miner figures out that if you put a sort in the request URL, it actually changes the direction of the users in the response. So I've come across that before. Again, it's completely useless. Obviously, you could SQL inject that potentially, so that's why it's useful to do it. It's not very useful for caching at all, because all you're doing is changing the direction. You're not actually injecting anything or reflecting anything. But in terms of actually answering your question, like how do you craft your payloads, it really depends on where your value here is reflected back. In this case, this was reflected back in a source attribute of a script tag. All right, and so we could easily just set up this URL and add some JavaScript there, and then we can show, hey, you can execute JavaScript, and we didn't even need to do any XSS, right? So yeah. All right, let's go get Aria. Does everyone? Do people want to continue with the web cache poisoning? Because there's some other ones. Oops. So there's stuff like unkeyed cookie, multiple headers, etc. We could do a couple of those. Maybe we'll do this one. I think this is the same concept, honestly. But if we go to this URL, right, let's make sure that this actually stopped. Okay, so param miner is still going, which tells you how many freaking things it has. So if you want to kill param miner, you basically have to unload it. So you see how it's doing this. So we can do shift click. Maybe it's control click. I think it was control click. I don't know if you can do it with that. I don't use that. But given that Albino Wax works for Portswigger, you can't get param miner. Oh, actually, I know. Actually, you can, because somebody wrote it and tagged him on Twitter, and he basically told them to change the name. He was like, "That's great and all, but can you change the name from param miner? Because that's kind of my tool for Burp Suite." So there is a tool, as a plugin for OSAP. I don't know what it's called. But the guy who wrote it was like, "Yeah, I named it param miner." Like, don't do that. That's like the people who freaking write a new version of Auto Recon. And just call it Auto Recon. Alright. So we go here, extensions, param miner, guest params. This is a cookie parameter. We'll add a dynamic cache burster as well. Parameterizer, yeah, I think so. I think it's different, isn't it, though? Right, yeah, this just literally tells you what it thinks the types of data is, I think. I mean, let's just install it and see, I guess. I think I use this. I guess I can just refresh the page. I guess we should probably click around. I don't see what it's doing. Like, presumably it should have found the product ID? Maybe? Why isn't it finding the product ID? You have to click around. I mean, I did. I clicked around. Literally, I clicked on 2 products. But still not finding the ID. Can I send it? It's a parameterizer? I guess I can. Yeah, I don't know how this works. They didn't find the ID parameter, which is weird. Alright, so what we are doing is running RAM miner. Where is it? It completed it, but it didn't find anything, which is weird. It should have found something. Okay, I'm gonna run that again. Alright. Extensions, param miner, guest params, cookie params. This is what it should be. It's all good. This is the pro version of Burp Suite. Okay, so it's doing it again. I'm not entirely sure why it didn't find anything the first time, but we'll see. Oh, it probably didn't find it because this is a... I see what it means. Alright. We don't even need param miner for this. We could have actually seen... if I actually add another good plugin. Reflected parameters, I think. Do this. Okay, let me just double check. So if I refresh this page, if I control refresh this page, well, I swear it reflection. Maybe it's not reflection. Is it reflector? There's so many freaking names. I honestly thought it was reflected parameters. There is an extension which tells you literally which parameters are reflected, and it should cover cookies. But anyway, what I saw, this FE host is a default cookie, and if we search for this prodcache01, you should see it. Yeah, here, look. Right? So it's reflected into this. So if we now go to this get request, send it again, right? Prodcache01. If we change this to Prodcache02, we should have the dynamic cache buster. I think we're doing that anyway. Cache buster is enabled. Okay, cool. So if we do this, and now we see 02, right? Here. So can we do some JavaScript injection here? We can. So what we can do is just do plus alert 1 plus. Can you imagine? The plus has got converted. We need to do percentage 2b. Okay. So if I keep... Okay, right. Now need to turn off the cache buster. And set something like cache equals 0. Right. We get a miss. We get a hit. Okay, now if we go copy this URL and paste it with the cache equals 0, we get alert equals alert 1. Alright. So what we're doing there, since we figured out that the cookie value here is being reflected in some JavaScript, like directly into JavaScript here, this is just basically forming, I guess you would call it a dictionary. So it processes this, and if we basically escape out of this string, concatenate it with an alert, and then put the string back together, we can do an alert there. So all we need to do now... Oh, alert 1 was what we needed. Okay. So the same thing again. Now we have something we know can get cached. All we have to do is take out this cache buster and just keep sending this. So we get a hit, get a hit, get a hit. And we basically just keep sending it, making sure it keeps getting cached until the user visits the page. And we should see that happen. Yeah, there we go. It happened. We didn't see it happen, but effectively it did. That makes sense. So basically the same concept. In this case, we weren't injecting into a we weren't injecting like here. We were injecting directly into JavaScript, which meant we had a bit more degree of flexibility in what we could do. So we could actually inject some raw JavaScript code. All right, DC-2. Let's add a new DC-2 empty. Do I need to... I'm still connected to the VPN, that's always good. Do you have auto recon running on the Mac? No, I mean, I don't use auto recon in my day job. I don't recommend using auto recon in production either. I don't think I even used it the last time I did an internal test. Auto recon is best left to just the old CTFs, to be honest. Yeah, it's pretty noisy. I mean, I know some people do use it. I don't know if that's a good idea or not. Realistically, it shouldn't be dangerous to use. Alright, so we have a server on port 80, so what we'll do... Unknown host DC... Oh, so we do need a host. Alright, let's just add this to Hackverter here. Not Hackverter. Project options, hostname resolution. DC2 is this. Alright, let's view the page source. Alright, is this a... This is a WordPress blog? So we should probably run WordPress. WP scan. So actually what I'm going to do is edit this now. So we actually add... that. Oops, come on. DC2. Alright, sudo service DNS mask restart. I'll just double check it works. DC2, perfect. Alright, So if we go here, results, scans, manual commands, there should be a WP scan. Here we go. What we want to do instead is just do DC-2 there. I want to soft wrap it. That should be fine. So let's do that. What is Tibbs? It's my name. Okay, let's see what this does. Did we find anything else? SSH on 7744. Interesting. Well, that runs. Let's see if we found anything else. Okay, so it is finding stuff with just the IP address. It looks like if you just visit / it redirects to DC2, but if you visit index.php itself, it goes there. I guess we could look at the license and see if we can get the version. Oh, maybe it's not in the license actually, is it? Readme.html maybe? No. Alright. Let's try robots.txt, although I don't think... If AutoRecon didn't find it, it's very doubtful. Yeah, it didn't exist. Alright, what do we have here? Okay, so... It's finding version 4.7.10. So let's do a quick Google. WordPress 4.7.10 exploit. Okay. It's SQL injection, but I'm not entirely sure if there's been any information on it. Oops. Okay. Anything else in here? Well, there's the sign up page, so we could always just try and sign up and see if we can actually log in as any kind of account. And oh, it found some users. Interesting. Admin Tom and Jerry. So we may have to... Yeah, I mean, okay, so we can actually try and log in using WSP scan as well then. Let's try brute force it. Alright, list of usernames to use. We're going to use admin, Tom, and Jerry. User share word lists. You can try RockU, I guess. /u, and then HTTP DC-2. Okay. We'll just do -e u1. Oh, u 1-to-1. Oh, is it just dash dash URL? That's why. Okay, and then yeah, you want to one. No, we don't update. Alright, so we're doing a password attack against 3 users. 7 minutes left. Obviously, we can still try. See if we get anything here. But it's looking more like, you know, I can't really find anything, or I should say I can't see anything here that suggests there's anything I'm missing, like a file that contains passwords or anything like that. So I imagine we just have to keep brute forcing, maybe? It is going pretty quickly, which is good. What was the version of WordPress again? So we can always just try search exploit WordPress 4.7.10. So we got authenticated arbitrary file deletion. And we've also got this viewing authenticated posts, which might be interesting. So if we do search exploit -m this and then have a look at the 4.7. Static equals 1 to WordPress URL should leak its secret content. Okay, interesting. So if we do this, all right. Your usual WordPress won't work, so instead maybe you just need to cool. More passwords always better, but sometimes you can't win them all. Oh, okay, yeah, so it is a brute force. But we're going to have to use cool, apparently. So we'll probably just cancel this. Alright, cool. Are we going to get this in 5 minutes? Who knows? Depth is 2. Alright, we're just going to do this. Alright. How many words we got? 293? Alright, screw it. Let's try this. Hopefully this works. While we're doing that, we'll just run cool again. We'll do more of a depth, I guess depth 5. Oh, shit. I hope I didn't fuck that up. I just basically deleted the words file. But I think because it loaded it already, we should be fine. Okay, so if I just do this again. Alright, the depth didn't do anything. So we hope that it should find a password this way. It did. Okay. We've got 2 passwords actually. Alright, let's do this. Can we get in another way? Log in. Sorry, this was Jerry. Okay, and what I'll do is an incognito window. WP. And we'll do Tom as well. How long have we got left? 2 minutes 40. Alright. We logged in here. Can we... Alright, are there any posts? All posts. It's just the admin. We can't edit anything, can we? Pages? Flag. Flag 2. You can't exploit WordPress and take a short. Oh, maybe we could use these passwords on the SSH. What port was SSH on? 7744. Jerry at DC-2. Yes. Okay. Let's try that again. Okay, maybe it's... Let's try this password on Jerry, even though it's Tom's. Okay, and now we'll try Tom. Oh yes!
You're in.
With 1 minute and 10 seconds to spare, all your doubters, the 66%ers. Ye of little faith. Honestly, the only reason I thought to try that was because I read that stupid freaking post. There is another way. I was like, oh yeah, I've got passwords. Will Tiberius get a user shell? Yes, yes he will. Complete prediction. Alright, we're gonna do sudo-l. No sudo. Oh, it's an r-bash. Interesting. So if I exit and do, isn't it dash t bin bash? Will this work if I get a proper shell? Maybe it's dash capital T. I always forget which one it is. Okay. We just... which one is it? Dash T... Yeah, it is lowercase dash t, but I don't know why it's not wanting bin bash. That might just be because the r-bash thing. Alright. We'll just do without. See what we got in this directory here. Okay, we got a bash history file. There's no cat command. Is there a tac command though? I guess we could do help. Can we use bin bash? Bash restricted. Cannot specify that in command names. Bash. And found echo path. Okay, so home Tom user bin. Oh my goodness. Okay, so we can. Alright, now here we go. So I could probably do use a bit. So I can't CD into anything, but I can run these. which means I can probably run user bin vi, or just I can just run vi. What am I talking about? Yeah, and then I can just do sh, right? Nope. Hang on. We're good. We're still good. GTFO bins. There is a nice way in doing it in VI to get a shell. That's all we need. Right, this one. DevNull is not a file. Restricted cannot specify that. Can I just do like just bash? All right. Maybe just less? This is gonna be some freaking bullshit escapes. Can I? Oops. Cancel. I want to quit. Can I like ls dot slash? I can. ls dot slash Jerry. Well, ls dash la dot slash Jerry. I guess we could. Oh, we could try less my bash history. That's fine. Oh, this is just my bash history. I don't think we're going to do this because we're in a stupid rbash shell. Yeah, I think we're done. Sorry, believers. What we can do with SCP? SCP? We can get a shell from SCP. Alright, hang on. Yeah, have we run out of time? Yeah. Alright, chaps. Well done to the people who said no. Honestly, this was the stupid rbash thing that screwed it. We gotta be clever about this because we can't echo, right? Well, we can echo. Make temp? No. So what we want to do is we want to echo this into a file. Sorry. Into test. Cannot redirect output. Lovely. I guess we could VI test then. I don't want that. I just want to. Come on. VI test. I just want this. Okay, let's try that. And now we want to chmod. Oh, can we even chmod, I guess? Maybe. Nope. There's a flag 4. Yeah, maybe I should have just... Well, I guess I should count the flag 3. Apart from there's no cat, I'd have to less flag. Poor old Tom is always run after. Perhaps he should SU. Oh my god, you kidding me? Could have SU this entire time? Oh no. Okay, good. I can't SU. I guess we could less /jerry/flag4.txt though. Get out of here. Do we have access to Git? No. Okay. We need to SU. Vim has 2 ways to escape. Yeah, the thing is I was in a rush. Oh, come on. Yeah, so we could do this, I guess. Maybe that was... Yeah, this is how we do it. Oh no. But I am in ID now. Oh my goodness. That was all I needed? Yeah, now we're in Bash. That was all we needed. See, this is time pressure. Time pressure. 5 minutes is just not enough to try everything. Because yeah, I just figured, hey, just go for this. It didn't work. I was like, okay, let's look at something. Boy, all right, now we can just SU to Jerry. Oh no, we can't. We need to find where SU is, which I'm just going to cheat and do which SU on my system. User bin. So basically, we don't have a path here. That's the problem. Okay, maybe not then. Is it bin SU? It is. Okay, it's bin SU. I can just cancel that. Okay, oops. SU Jerry. We have Jerry's password somewhere. Oh, it's all the way up here. Crap, I should have copied Jerry's password. There we go. Okay. Are you kidding me? I copied that. Oh my god. All right. This is a bad idea. I didn't realize Jerry was... There we go. Copy that to here. There we go. Okay. Alright, let's do that again. Okay, now with Jerry. Now we can just, yeah, I mean, we don't need flag 4. sudo-l. Oh man, we could have got so close. Oh, okay. Sudo git.
We are in.
Disappointing. Did this thing even have like proper flags to report? It did, okay. So home, Tom, local.txt, and then cat root proof. There we go. Alright, any questions about any of that? I'm enjoying having people gamble on my stream. It's kind of fun. Please follow me on Twitter, join the Discord server, subscribe to the YouTube channel, and of course, follow me on Twitch if you're not already. Follow me on Twitch. You'll get alerts when I go live, especially as well as you join the Discord server as well. And there's a good community over there. So, all right, people. Thank you so much. I will see you next week. Same time, same place. And let's raid, ending with Ali.